I used to think we perceived the world, then acted accordingly. I see a glass of water, so I go and pick it up. However, when we look at the traditional explanations of perception a little bit closer, there are quite a few problems with this idea. But the biggest problem, I think anyway, is that the ideas don't really talk about action. The ideas suggest we sense something, but that isn't good enough on its own. So something uses cues, rules, and most likelihoods to interpret what we sensed, the stimulation, for us to understand the world. Then we act on that perception. But as I described, when we're experiencing the bullshit chair illusion, when we move, the illusion is revealed. It isn't a chair, and the people are actually similar sizes. And we're always moving, acting in the world, with lots of different senses perceiving the world at the same time for this thing to interpret while we move. Traditional approaches started with visual perception, using the retinal image. But as discussed before, there are different types of eyes which couldn't have a retinal image, like compound eyes, the kind of eyes flies have. And having a 2D image of the world also isn't really how chambered eyes, the ones humans have, works. We detect information from the world, but how we use that information to act is critical to help us understand how and why we behave in the world. The information from the world is often described as impoverished or not enough. That is why we need interpretation, cues, rules, and most likelihoods to perceive the world, done by the often named central executive. But as discussed before, there are lots of issues with the idea of a central executive. So ecological psychology suggests the information is actually enough. Instead of the light not carrying properties from the world, things like height, width, or angle to help us recreate an accurate representation or copy of the world in our head, ecological psychology suggests information is specifying. It is unique, not special, interesting, or a little different. The information is like no other, one of a kind, which means the information is unique and specific to just that situation. At this point, it's worth noting 3 ways light travels. Light is electromagnetic radiation. It radiates from a source, like a light, and is electromagnetic energy. This is different from kinetic or potential energy produced by movement or the potential of movement. One part which makes electromagnetic energy different is their wavelengths. Only some wavelengths can be seen by humans, visible light. But when we see white, we actually see lots of different colours which can be split by a prism, something you've probably done at school or seen online somewhere. When light strikes a surface, it can be mirror reflected, scatter reflected, or absorbed. Mirror reflection means the light bounces at the same angle it struck the object. Just like when we look at ourselves in the mirror, we can see ourselves. Scatter reflection also does as it sounds, bouncing off in different angles, often off a rough surface. And absorption is where the energy is transferred into something else. Often in this case, heat, the sun, light source, making things hot. This matters because traditional ideas assume light reflects from surfaces and travels in straight lines, then creating the retinal image, which isn't wrong, but oversimplifies how we detect light. As we move, we detect the uniquely structured light from the different ways it travels. Mirror, scatter, and absorption. But light also interacts with each organism in a unique way. We are all different heights, with different visual capabilities. I have impaired vision in my right eye, so closing my left eye would make it very hard to move without walking into something I did quite a lot when I first lost my eyesight. So we don't detect all light. We detect the light unique to the observer location and capabilities. If we consider other organisms, they also have different capabilities to us. So the argument here is that the information from the light is specifying because of the unique way light travels and the unique location and capabilities of the observer. Again, considering the organism-environment relationship rather than just the organism. These seemingly small changes have actually a huge impact. The environment now playing a much larger role in explanations of perception and action at the start and end of any measured process. A coupling of perception and action. Intentions driving behavior, which impacts the relationship to the environment, which alters the detection of specifying information, and the cycle continues. Those properties, height, width, and angle, not being relevant. Traditional approaches consider a static image, the retinal image, and compare that to previous images, removing movement from this process. Is height bigger or smaller? Is width bigger or smaller? Then interpreting what all that means through all movements. Movement being the problem perception needs to wrestle with, our brain processing, whatever that means, all of this extremely quickly. But the ecological approach doesn't see movement as a problem or look at a static image. It considers movement as a feature of perceiving. As structured information is detected through movement, there is only one situation that experience could have happened. When we walk up to an object, like a tree, a relationship to the size and position is specified. There is enough information. This is described as revealing invariance. When we move, some things will change and others won't. A tree won't move or become smaller as we walk up to it. Invariant. But the Bouchet chair illusion, the chair was revealed as something else. Variant. In science, something that happens the same way, regardless of circumstances or context, is called a law. Gravity is a law of physics. It is invariant. So when walking up to a tree, the particular relationship between us and the tree is lawfully structured. The information is uniquely structured, and the relationship is built on invariance, thus is lawfully structured. This is very different from the ever-changing copy of the world using static images, like a video playing lots of static images one after the other. The organism-environment relationship lawfully generates information through movement, which uniquely specifies the relationship. How the information is generated and specified will be discussed in more detail in future videos, but let's just take a step back. Instead of the stimulation being bad and need fixing, James Gibson suggested it might be fine. And actually, good, unambiguous, and rich with useful information. If we take this alternative approach, we don't need to fix a bad image, explain anything to do with a central executive, or worry about actions after perception. A system that computes meaning needs an entity, like the central executive, to do the calculations, often described as subconscious calculations. But a system that detects information and meaning doesn't need that entity. In the book, An Introduction to Ecological Psychology, they use a mercury thermometer as an example. It doesn't compute or infer the temperature. The mercury directly responds to the change in temperature in a lawful and reproducible way. No thinking entity needed. In addition, the variables that are discussed in perception are also different. If an ice cube melts, we could describe the experience through physics. The water in the ice cube didn't stop existing, it changed from solid to liquid, then maybe liquid to gas. But I can't grab the ice cube anymore. My experience changes as it melts, impacting what I can do. And the physics doesn't really explain that. For light, wavelength and amplitude are discussed in physics, but these don't really help us understand what we perceive. Ecological psychology call these lower order variables, as they are microscopic physical properties. In the traditional Helmholtzian approach to perception, this is what is suggested we use: wavelength and amplitude through cues, rules, and most likelihoods to compute an answer. Similar to calculating the area of a rectangle, length and width as the lower order variables, and the area as the higher order variable. The problem is that if we look at the lower order variables, we can't really do anything with them without calculation, the central executive calculation. Perception and physics are just different languages to describe a situation. So ecological psychology just ignores lower order variables and starts at the higher order variables. But how? We need to calculate the area of a rectangle, right? Length times width. Well, in 1854, a Swiss mathematician created the polar planimeter. Easy to say. No electricity, no computer, just gears, wheels, and a dial. This tool measures the area of shapes, but can't measure length or width. It directly measures area, the higher order variable. Let's just emphasize that. It can't tell you the lower order variables, the length and the width, but can tell you the higher order variables, area. If a tool can do this, could an organism? Ecological psychologists say yes, which begs the question, what is the area equivalent in perception, or organism perception? Simply put, affordances. But there is loads to unpack there, which I will go through in future videos. But something else that should be emphasized at this point, which is going to sound extremely weird. We don't perceive light, we perceive if something can be grasped. We don't perceive sound, but the layout of surfaces. We don't perceive pressure on the skin, but the usability of a tool. The medium is not the message, not lower order variables, higher order variables. Perceiving the full context of your experience consuming this video, not looking at the microscopic physical properties of the device you are using to watch this video. Ecological psychology challenges problems with traditional approaches to perception, and I go into more detail about that in this video over here.